and 1, 3, 3, 1. Oh, no, there we go. We're looking for patterns in Pascal's triangle. So you've probably already gone over some of the patterns. We looked at how these numbers in Pascal's triangles can actually tell us how many different pathways there are to get to a particular location. And that the pathway to, say, this location can be found just by adding the number of pathways to get to the position above that location. Okay, we're going to look at two more patterns in Pascal's triangle. And so we're going to look at the perfect square. There's a sequence of perfect squares in this triangle. We have to do a little bit of work to find it, but it's there. So the perfect squares go 1, 4, 9, 25. All right. So let's see if we can find a 4. So if we add those two terms together, the 1 and the 3, what do we get? Right, that's right. I'll just assume everybody knows how to add 1 and 3. You get 4. But look at this. When we add the 6 and 3 together, we get 9. And down here, if we add the 6 and 10 together, we get 16, another perfect square. And then if we were to continue the table down here, this would be a 25. Or sorry, definitely would not be a 25. It would be a 15. Poor little 15. It can't really fit in there. But there we go. That would be equal to 25. So if we look at that, if we look at summing those down that diagonal, we see the pattern of perfect squares comes up. So you can actually, and you'll be able to see a relationship in the term numbers here. So 4 is equal to term. So that's row 2. So the rows go 0, 1, 2. And it is term 2 because they go term 0, term 1, term 2. So term 2, 0 plus term, sorry, definitely not 2, 0. Term 2, 2 plus term 3, 2 is equal to 4. And for 9, very similar. Term 3, 2 plus term 4, 2. Okay, and there's where all the perfect squares come in. So we can see perfect squares in Pascal's triangle by adding the numbers down one of the diagonals. And we could also add them down this diagonal. We get the same pattern. Okay, we're just going to look at one more pattern that shows up in Pascal's triangle. So we're not doing a really super exhaustive job here. So let's see, that's a, oh, how did that 9 get in there? I know how that 9 got in there. 1, 4, 6, 4, 1, and 1, 4, 10. Okay. Notice it's symmetrical about the center as well. Okay. The second pattern we're going to look at are the triangular numbers. Okay, so the triangular numbers, they go like this. It's like we're building triangles with little dots. So the first triangular number is 1. Now we're making a second triangle. This time we made a bigger triangle with 3 dots. So this is 3. And then to make the next triangle, we add 3 at the bottom and we get 6. And then we add 4 at the bottom. And we get 10. And so this is known as the triangular numbers, this sequence, 1, 3, 6, 10, etc. And if we look in Pascal's triangle, once again, looking at a diagonal, if we look at this second diagonal, You can see the triangular numbers 1, 3, 6, 10, and they would continue on down following that pattern of the triangular numbers. So these are just some of the patterns that show up in Pascal's triangle. One of the things you should become familiar with is how to identify the term numbers. And we'll do a little bit more on Pascal's triangle. It actually gets more interesting from here. That's all.